Welcome to Unit 3, Lesson 2. This is our last lesson for this unit. It's a very short unit, and it does just piggyback right off of what we learned about equations. All right? So let's just remind ourselves of the translations for inequalities when it comes to the word problems, okay? I do want us to think about the number line, so let me draw that. And then I want to remind you that whenever you see this arrow going to the right, if you think about that, it looks an awful lot like an inequality, okay? Words that would look or represent that inequality would be no less than and at least, and these would also include the equal to line under it. Also, the phrase is more than, okay, would be greater than. And let me add the word is more than here, okay, or is no less than. You're always going to see the word is in front of it, and that tells you that it's an inequality and not subtraction, okay, or not a turnaround word with subtraction. So on our number line, whenever we're going this direction, our numbers are getting bigger. So just a way to help you remember, okay? So I've got 1 or 2 or 3 or 4 or 6 or 100. Okay, my numbers are getting bigger when I go that direction. What if I'm going the other direction? Okay, when I go this direction, my numbers are getting smaller. So -2, -4. So they're getting smaller. Below, the words that would indicate to me that it's getting smaller would be is no more than or is at most. Okay, and that would be the less than or equal to. And then the other option is less than. Okay, as I go through these word problems, I will be color coding my inequalities, and I'm going to constantly be checking back to this part of my notes. So whenever you're translating something on your own, during your homework, during your quiz, during your test, I want you to always be, well, maybe not during the test, but at least for the other parts, be referencing this little list of translations right here, okay? Until you start to learn or remember which phrases mean which sign, all right? Okay, now when we go through these next 7 word problems today, we are going to be reading carefully and underlining our key words. And of course, I try to circle some things as I go to and write my translations right up above the words, okay? We will need to determine, so I'm going to be using either red or green, and I will circle, okay, based upon which symbol that we need to use. Again, red will be the less than or equal to. Green will be the greater than or equal to, okay? Finally, we are going to write our inequality statement and then solve it out, okay? So let's look at example number 1. I have 5 less than, and this is why I put in the notes over here the word is in front of everything. Do you see is less than right here? Okay, the phrase or the word is in front of it tells you that it's an inequality. Over here, it just says 5 less than a number. And that means that's the turnaround phrase where I will subtract 5. Okay? So 5 less than a number is going to be the X that goes in front there, is at most 11. Okay? If you look up above, Is at most is our less than or equal to symbol. Okay? What I'm going to do now is just solve this equation or inequality. So plus 5, bring down the x, these canceled. 11 plus 5 is 16, and then I will bring down the inequality. A lot of students will get all the way through their work, and then they will put an equal sign in their final answer. And that is technically wrong. Okay, x does not only equal 16 in this situation. And so I also want us to continue sketching out our solution set on the number line. So pause this video and then fill in your correct number line with your circle and your arrow. And let's see if you can remember how to do that from our first lesson. All right, so I've gone ahead and graphed my solution set for example number 1. Hopefully yours matches mine. Let's go ahead and move on to number 2. 3 times a number increased by 4 is at least, so the is gets circled there, at least means greater than or equal to 16. So I'm going to bring this down below. 3x plus 4, 16, and it's greater than or equal to. I'd like for you to pause the video and practice solving this all the way through. All right, and the answer that I got when I solved it was x is greater than or equal to 4. Draw your number line and go ahead and draw your solution set on your number line. All right, so I've gone ahead and shown you my work, and I've also graphed my solution set. I used green for my arrow this time because it is at least, 4 or greater than or equal to 4, which means that it's going towards the positive numbers. All right, and I did have a closed circle there. I want you to pause this video and try to complete number 3 on your own. It's very similar to what number 2 was. So I want you to practice and see if you can do this on your own and grow some more confidence with these word problems. All right? So please hit pause. All right, welcome back. I'm about to show you my solution for number 3. Hopefully you were able to get this solution as well as this graph. Is greater than did not include the equal to line underneath it. So when I graphed this, I needed to be sure that I left my circle open. All right, let's go look in number 4. I want you to notice that in number 4, I did cross out the word odd. I told you I'm going to save that concept for next semester, all right? So cross it out, and we're going to do this just as a regular consecutive integer word problem. All right, the sum of 2 consecutive integers. So let's remember what we do for consecutive integers. 2 consecutive integers would be the first number is just x, and then the second number is x plus 1, okay? Is at most, the word is there tells me this is an inequality, and at most means less than or equal to. and then 16. All right? So the sum of the two integers that I have here is going to be at most 16. So it's going to look like this. X plus x plus 1 is less than or equal to 16. All right. I want you to pause the video and then try to solve this on your own. Let's see what we can remember. I'm combining my like terms. I'm going to move away the constant term. And I'm going to divide by the coefficient of the variable term. Okay, x is less than or equal to 15 halves, which is the same as 7 and a half, which I'm going to write as a decimal. You could also write that as 7 and 1/2 as a mixed number. All right, I now want to look at my question again. It is asking me for the larger integer, okay? So what number would come after this one, even though it's not an integer? That's probably because we took out the word odd and it affected our answer. But we'll just go with what's the larger number, okay? And so what I need to do is add 1 to that, because we had x and x plus 1. So the answer I need to give them is 8.5. All right? Awesome. Great job. I want you to pause the video and see if you can do number 5 on your own and practice with the consecutive integer problems. After doing your translation, you should have gotten this for your inequality that you need to solve. And I got the solution, x is less than 9. If I double check the final question, it's asking me for the smaller integer, which is just x. So it is just what I got. X is less than 9 is my final answer. Let's move on and look at number 6 together. All right, Keith has $500 currently in a savings account at the beginning of the summer. He wants to have at least is going to be greater than or equal to, okay? So that's where that information came from. 200 in the account by the end of the summer. So 500 at the beginning, he wants to have at least 200 in there by the end. So at least means greater than or equal to 200. All right, and he is withdrawing. Withdrawing means taking money out of the account. He's taking out $25, and he is doing that each week for his spending money for food, clothes, and movie tickets. So I'm going to put W for weeks, okay? And the question is for how many weeks, which again is why I use the W. W equals weeks. Can Keith withdraw money from his account? All right. So let's start to solve this together. Okay, here is my, let me do a pink rose line. I should have been doing this all along. I just haven't. Because I was using red and green for my inequalities. So let's use pink for the rose line. So my W is on this side, so I'm going to go ahead and subtract the constant term from both sides. Again, the constant is the number that's by itself on the same side with the variable. Bring down my variable term. Bring down the inequality. 200 minus 500 is negative 300. My next step is to divide by the coefficient of the variable term. So negative 25, negative 25. These will cancel out. Bring down your W. And if you think about how many quarters are there in $3, 300 divided by 25 is going to be 12. All right. And a negative divided by a negative will give me a positive 12. Now, notice that I did not yet bring down my inequality because I want to stop and just remind you of what happens when we divide by a negative. Okay. We have to apply the golden rule, which is to flip the inequality the opposite direction, okay? And then let's read what this actually says. W is less than or equal to 12. This means that Keith can withdraw money out of his account for 0 weeks, for 1 week, for 2 weeks, for 3, all the way up to 12 weeks. But after 12, he cannot pull out any more money. So it is 12 and then less than 12, okay? At 12 weeks, it would mean that he has 200 remaining in the account, and that's what he expects to leave in there and not touch, right? Hopefully that made okay sense on why it still makes sense, even with a word problem, that applying the golden rule and rotating that inequality, okay? Let's look at our very last example for today. Yellow cab taxi. They charge a $1.75 flat rate in addition to 65 cents per mile. Okay. Katie has no more than means less than or equal to. No more than $10 to spend on a ride for the taxi. How many miles? So M is going to equal miles. Right there it told me. How many miles can Katie travel without exceeding her limit? So let's bring down our equation. 1.75 plus 0.65 miles is less than or equal to $10. Pause the video and try to go through and solve this on your own, and let's see if we can come up with the same solution. All right, I did show a good part of my long division that I did here. I just ran out of room to keep going. So I'm just going to leave my answer at M is less than or equal to 12.6. Okay, and then let's go ahead and graph what that looks like. And here's what my inequality looks like when I graph it. It's a closed dot because 12.6 is included. And I did stop my picture at 0. A taxi cannot drive you less than 0 miles to somewhere. So I just stopped it right there at 0. This will not continue on in that left-hand direction forever. All right? Hopefully we are feeling more comfortable with the inequality word problems, especially since we've already done the equations word problems. And so this is kind of like a little review for us as far as the translating and then the solving goes, okay? What I'd like for you to do now is to try tonight's homework, which is another quiz is assignment. Give that a go, and let's see how you do. Also, if you flip your paper over, there is our Unit 3 review for inequalities, and there are 5 additional word problems back there that you will be responsible for solving for a grade. So go ahead and when you've got the opportunity, try to do those 5 as well, okay? Be sure to show your work just like we did in our notes. All right, that's our last video for Unit 3.